The diagram shows the curve with that equation. The curve is stationary at the point P, which is 0, 5, and the point Q. Find the coordinates of point Q. So stationary point means that the dy by dx is equal to 0. The gradient is 0. So if I differentiate this function, I'm going to get 3x squared minus 6x. If I make that equal to 0, then I can factorise this. I can take a 3x outside here. So I will have x minus 2 on the inside. So I've got two solutions. I've got the x equals 0 or x equals 2. The x equals 0, that corresponds to the stationary point P. The x equals 2, therefore, corresponds to the stationary point Q. All I need to do now is to work out the y coordinate. So if I substitute 2 into this equation here, so 2 cubed minus 3 times 2 squared plus 5. So 8 minus 12 plus 5 is 1. So that's the coordinate Q. That's part A of this question. Part B. We are told that the straight line passing through the point P and parallel to the x-axis intersects the curve again at point R, and we need to find the coordinates of point R. So I want to be able to work out the equation of this blue line. Then I can do some simultaneous equations to work out the coordinates of point P, point R. Now, remember, this point here is the point y equals 5. I know that from the y coordinate of point P. So therefore, this line is just very simply y equals 5. The y coordinate is always 5 on this line. So if I take my curve, the x cubed minus 3x squared plus 5, and make that equal to 5, take the 5 away from both sides, factorise, so I can take an x squared outside here. And now I can see that x equals 0 is one solution, or x equals 3 is another solution. The x equals 0 obviously corresponds to the point P here. The x equals 3 must correspond to the point R. And to work out the y coordinate there, well, we already know that the y coordinate is 5. So that's the answer to part B of this question. Part C, I'll do that. I know you didn't ask me about that one, but I'll do it as just in case. So we want to find the area of this shaded region here. So to do that, I know that I can integrate. If I integrate between 0 and 3, that will tell me the area underneath the curve. So if I integrate between, so if I do the calculation, the integral between 0 and 3, because the x coordinate here is 0, the x coordinate here is 3. So if I do that calculation, if I integrate the curve between 0 and 3, it will tell me the area between the curve and the x-axis, between those two x limits. So that will give me a quarter x to the power 4 minus x cubed plus 5x. Substitute the 3 in. Then substitute the 0 in. And actually substituting the 0 into all of these terms will just give 0. So if I work that out on the calculator, that will give me this red area. But obviously I didn't want the red area, I wanted to work out the shaded area, the blue area here. So to work that out, I will just do the rectangle So that's this rectangle here, which the base is 3, the height is 5, that's 3, that's 5. So the area of that rectangle is 15. So the shaded area then will be the 15 minus your answer from down here. And that will be the area of the shaded region.